Geological investigation. Geology plays a very important role in the field of civil engineering. It provides knowledge about materials used for construction, a knowledge and which is helpful for constructing dam, road, curve, and etc. It provides a systematic study of structure and properties of construction materials and their components. The civil engineers need to know the properties of rocks accurately to enable them to consider different rocks for any required purpose, that is a foundation rock, as road metal, as concrete aggregate, as building stones, as the roofing materials for decorative purpose. The selection of a site is important from the viewpoint of the stability of foundation and availability of construction materials. Geology provides knowledge about the site used in the construction of buildings, dams, tunnels, tanks, reservoirs, highways, and bridges. Geology helps to identify areas susceptible to failures due to geological hazards such as earthquake, landslide, weathering effects, etc. The knowledge about the nature of the rocks is very necessary for tunneling, constructing roads, and in determining the stability of cuts and slopes. The condition problems of dams, bridges, and buildings are directly related to the geology of the area where they are to be built.
The knowledge of groundwater is necessary for connection with excavation works, water supply, irrigation, and many other purposes. Hydraulic maps provide information about the distribution of surface water channels in the groundwater table. Geological maps helps in planning civil engineering projects. It provides information about the structural deposition of rock types in the proposed area. Geology helps in determining the earthquake-prone areas. If any geological features like faults, folds, etc. are found, they have to be suitably treated to increase the stability of the structure. The knowledge of erosion, transportation, and position, or ED, by surface water helps soil conservation, rivers control, coastal and harbor works. A geological survey of a site before starting a project will reduce the overall cost. Dams, reservoirs, tunnels, highways, bridges, and buildings, among other key civil engineering projects, are built on rocks or soils. As a result, it is critical for the engineer to have a thoroughly understanding of the strata or soil through which construction work will be carried out or on which it will be supported. The structure may have significantly greater cost if the geological parameters of the locations or alignment are not correctly examined or evaluated. Furthermore, their stability may be endangered. Many dam failures, building foundation failures, bridges and tunnels collapse have been linked to a lack of understanding of geological conditions in and around these facilities.
The main objects of geological investigations for most engineering projects are to determine the geological structure of the area, the lithology of the area, the groundwater conditions in the region, and the seismicity of the region. The geological structure of the area, which also includes topography and geomorphology, is to determine by conducting extensive and intensive geological surveys. These surveys will reveal the entire topographic details. Example, the existing of hills, slopes, valleys, plains, and plateaus, occurrence of faults, faults and major unconformities in joint system. Geomorphic details of water bodies like river, lakes, springs, and drainage system. The lithological details as revealed by this investigation should include the type of rocks that make up different parts of the area on the surfaces, also up to and even beyond to a desired depth. Their textures, major structures, and physical engineering properties like hardness, strength, modulus of elasticity, rigidity, porosity, and permeability. The groundwater conditions are of great significance in all major engineering structures. The relative position of water table with respect to the project must be thoroughly established, and all variations in it during different periods in a year should be ascertained. Whether our proposed project will be much above the local and regional water table or below it, or will intercept it in some areas shall determine to a great extent the ultimate design and stability of the structure, and hence its cost.
The seismic factor has become a parameter of great concern during last 60 years or so. Many cities, towns, and villages in different countries of the world have been devastated by earthquakes. In some cases, areas hitherto declared seismically safe witness serious seismic activity resulting in catastrophes. For any type of civil engineering construction in a region, its seismicity has also to be studied critically. Methods of geological investigations. These may be divided into two main groups: A. The surface investigation, and B. The subsurface exploration. Surface investigations. This includes preparation of topographic maps using normal mapping techniques. In fact, all field surface investigations. These include preparations of topographic maps using the normal mapping techniques. In fact, all field surveys begin with the preparation of topographic maps below, showing elevations, contours relative to some data. Aerial surveys and preparations of photogeological maps are the latest methods of surface investigations. The entire area involving an engineering study is photographed using sophisticated cameras and controls from low-flying aeroplanes. These maps are then interpreted to provide sufficiently accurate geological details of the area.
Geological investigations. Photogeology is a branch of geology in outright and fast acquiring an important place. This is scope enlarged by mapping of vast areas of the globe through satellites. Imaginaries obtained from the satellite surveys. Aerial surveys, when interpreted properly, provide and useful details regarding rocks, outcrops on the surface with possible estimating subsurface configurations. Photogeology is a study of geological features through the aerial photography, and its study of the structural elements of the three earths through taking photogeology using aircraft without being contract with an it is form of remote sensing. Geological investigation. Hydrogeological surveys to obtain hydrogeological details of the area are also conducted partly on the surface with view recording. Following details that are immense help in the later studies. Hydrogeologists and skill they provide are the use of prevent clean groundwater from the becoming polluted, or to restore formerly clean water supplies and not become polluted and not need to be cleaned up. In some situations, groundwater may not be benefit but hazard to health and safety of the public. Next, geological investigation, drainage pattern of the area and discharge. Drainage pattern recognition helps to provide a qualitative description of the terrain for analysis and classification and useful for terrain modeling and visualization of an application in environment. Such research has been done on the description of drainage pattern in geography and hydrology. Next is location and discharge details of the spring and other leakage points. Importance of geological maps represent distribution of types of rocks and surface sophical deposit as well location of geologic structure such as faults and fault geologic maps and the primary source of information for various aspects and land using including setting of building and transportation systems. Presently, discharge monitoring aids in detecting climatic of environmental changes because the discharge and quality of the river water function many climatic, biological, geological, and topographic variables coexisting in the basins. First, location of wells, measurements of water levels after intervals to note aberration in behavior with time. Best location of wells. The best well site is an elevated area which allows any surrounding surface, water or rain to drain anyway from your well. This helps prevent contaminants from entering your well waters. Also, they stay away from the stepstone slopes. Next is precipitation of evaporation details. Precipitation is the water released from the clouds in the form of rain. Freezing, rain, sleet, snow or hail is the primary connections in the water cycle that provides from the delivery of atmospheric water to the earth. Most precipitation falls of rain. Geological investigation or surface surveys, however carefully carried out, can give only superficial details. This could broadly enclose primary surveys and have necessary to be followed by well-planned surface investigation which should provide fairly accurate idea about subsurface geological condition at the most critical locations.
Geological investigation. B. Subsurface exploration. These are accomplished by the following two broad methods: direct subsurface exploration and indirect subsurface exploration. A direct method involves examination of rock or materials of the underground by digging of drill holes, tile pits, adits, shafts, galleries, and exploratory tunnels. In such explanation, both the underground areas are reached. Two direct examination and testing or examples are obtained which are examined and tested in the laboratory. The indirect methods of subsurface exploration are used extensively and involve application of geophysical techniques for obtaining fairly accurate idea of subsurface geology. Geological investigation. Objectives of subsurface investigation. Number 1. Identify and delineate geologic units. Number 2. Identify features such as joints, faults, and silicious sites. Number 3. Describe the unit systematically, include information on field identification and extent of weathering of density or compressibility. Number 4. Conduct simple index test during investigation. Number 5. Assess hydrogeologic conditions. Number 6. Extract samples of geologic units and underground water for laboratory testing. And last,
Initial coverage reflect the purpose of investigation, subsurface variability, and stage of project implementation. Like covers the project area, should also cover outside of the perimeter if needed. To assist influence on surroundings, facilities, and influence subsurface conditions outside the project area on the work of hands. There is two types of methods. One is intrusive methods and the other one is non-intrusive methods. Intrusive methods consist of drilling, sampling, and situ testing, test pit excavation, and trenching. Non-intrusive methods consist of seismic velocity profiling and ground penetrating radar or known as GPR and electromagnetic resistivity surveys.
Classification of geophysical methods. There are many kinds of methods in geophysical investigations. These methods are magnetic method, seismic method, gravimetric method, geothermal method, electric method, and radiometric method.
Magnetic method. The magnetic method involves the measurement of the Earth's magnetic field intensity. Typically, the total magnetic field or vertical magnetic gradient is measured. Measurements of the horizontal or vertical component or horizontal gradient of the magnetic field may also be used. Magnetic method. Like gravity method, these investigations also take advantage of natural magnetic field associated with the Earth and its relation to subsurface geology. Controlling property. The main controlling physical property in magnetic method is magnetic susceptibility. Principle. In general, when the magnetic field of the Earth or one of its components is measured on the surface, body possessing magnetic movements different from those of the surrounding rocks contribute to the deviations in measured quantities. For the magnetic anomalies, it is possible to locate anomalous projects. Magnetic method. The different parameters measured during magnetic investigations are total magnetic field, intensity and direction, and different space components. Magnetic surveys have a certain inherent limitations. Hence, for unique and accurate solutions, magnetic prospecting is often carried out along with gravity or other methods. Magnetic methods are based on the fact that the magnetic body's presence in the Earth's surface contribute to the magnetic field of the Earth. Magnetic method. Application of magnetic investigations for delineations of large structural forms favorable for the accumulation of oil and gases, for detection of and location of faults, for locating strongly magnetic iron ores. By virtue of their inexpensive nature and easy operations, magnetic methods are widely used for detection.
Seismic method. Controlling property. Elastic property difference in rocks and the controlling property. Principle. Field of study is based on the principle that subsurface rock formation bear different elastic properties. Because of this, the velocities of propagation of seismic waves through the subsurface layers of Earth suffer reflection
of critical reflection arrive at the surface of the Earth where they are detected by geophones. From the time taken by the waves to arrival through the subsurface formation and the seismic wave velocities of the media, it is possible to determine the depth of various with the help of geophones peaks at suitable intervals of the ground. The different seismic waves reaching the surface are recorded and from the time of their arrival time. Distance curves are constructed. The direct wave are the first to reach the geophone's place between point and the end distance beyond the point is called the critical distances. Depending upon whether reflected waves or refracted waves are used in the investigation, there are two types of methods, namely seismic reflection method and seismic refraction method. A geophone and amplifier and the galvanometer are the basic units required for reflected or refracted wave registration. Seismic refraction studies are effective for depths more than 100 meters but are suitable for shallow exploration. Refraction methods are employed for investigation deep from close to the surface to several kilometers deep. These methods are followed for the investigation of deeper crush under seismic studies. Shallow seismic refraction have found effective application in investigating the suitability of foundation sites for civil engineering structures. Seismic method, refraction versus reflection. Seismic refraction is the signal returns to the surface by refraction at subsurface interfaces and is recorded at distance much greater than depth of investigation. Seismic reflection is the seismic signal reflected back to the surface at layer interfaces and is recorded at distance less than depth of investigation.
Gravimetric method. Gravity method represents a set of geophysical methods which make use for natural gravity field of the Earth. Physical property, density of the material is controlling the physical property. Gravimetric method is a describe of set of methods used in analytical chemistry for the quantitative determination of an analyte or the ion being analyzed based on the mass. Principle. A gravimetric method, the nature distribution of gravity G on the surface is analyzed. The gravity influence positively if the causative body is heavier, larger, and occur a shallow of depth. The principle behind the gravimetric method is the test of the mass of an ion in a pure compound and can be determined later used to find mass percent of the same ion in a known quantity of the impure compound. Gravimetric method choose a particular region, surface bodies such as ore deposit, coal seams, and the salt domes, whose densities are different from the surrounding rock axis. The gravity field deviates from the normal value than expected from the deviations. It's possible to locate the homogeneous bodies in the surface. The primary goal of studying detailed gravity data is to provide a better understanding of the surface geology. The gravity method is the relatively cheap, non-invasive, non-destructive, and non-sensing method. Has already been tested for a lunar surface. Precipitation. Gravimetric analysis share two important attributes. First, the precipitate must be low solubility and high purity. And non-composition, if its mass is to reflect accurately the analyzed mass seconds must be easy to separate the participants from the reaction mixtures. Gravimetric method as an advanced limitation, gravimetric analysis usually provides the analyzed in single element or limited group of elements at a time. Four methods are often evaluated, convoluted, and slight misstep in procedure can often mean disaster of the analyzed. Colloid formation, precipitation, gravimetry for the example. Gravimetric method measurements of gravity provides information about densities of rocks. Underground, there is a wide range and density among the rock types, and therefore geologists can make inference about the distribution of the strata. We are attempting to map and surface faults, because faults commonly juxtapose rocks and differing densities, and gravity methods an excellent exploration choice. Gravimetric method has advantages. It's used to determine the anatomic masses of many elements to 6 figures accuracy. It creates of little room on instrument error and does not acquire series of standards for calculation of an unknown. Gravimetric investigations. Gravity investigations are useful in exploration of ore deposits. The objective of exploration is to simply discover the deposit a volume of rock of sufficient mineral and metal grade that can be mined and produced economically and cost effectively and efficiently as possible. This is a primary metric by which of judge exploration team. Second is in solving regional geological problem. A kind of solving geologists solve problems associated with pollution and waste management, urbanization, and natural hazards such as flooding and erosion. Third is exploration in oil and natural gas deposits. Gravimetric prospecting is a geophysical technique which is able to identify anomalies in gravity, accelerations, generated contrast, and density among. 3 geophysical methods used in petroleum exploration comprise magnetic and gravimetric and seismic, including the reflection and reflection techniques. The next is in solving some engineering problems. Step in solving in real-world engineering problems. Define the problem, list the possible solutions, evaluate and rank the possible solutions, develop a detailed plan of the most attractive solutions, re-evaluate the plan and check feasibility, implement the plan, and check the result. Next is gravity investigation and carried out always oil gas investigations. Gravity is a method of relative cheap, invasive, non-destructive remote sensing methods that has already been tested on the lunar surface. It's mainly used for oil exploration. Gravity prospecting involves in measurements of variation in the gravitational field of the Earth. Next is because of their spatial success in the area in case of engineering problems mapping dam sites, earthquakes. The following main factors examine the stages selection, dam types, topography, and geological conditions of the proposed dam site, availability of sustained materials for dam, and feasibility still reconstruction that lead to able to meet the condition extreme flood and earthquake. Next is problems tracing buried river channels, gravity methods, and considerability useful. Concrete embankment dams are much better suited horizontal than the buildings because large dams are not able to withstand earthquakes. It's written a period of 10,000 years, whereas building bridges is usually designed for earthquake with a written period of 475 years. If necessary for safeguarding the people's health. If there is no proper drainage system, water will stagnate and stagnant water becomes the breeding place of the harmful insect. Second is necessary proper discharge and water of wastewater, rainwater, and runoff, and efficient flood control.
Geothermal method. Their method are latest additions to the group of geophysical method, controlling property, their conductivity. Principle. Temperature distribution on the surface of the earth is due to the three different sources. There are heat received from the sun, heat condensed from the hot interior of the earth due conductions and convections processes. Heat due to decay of radioactive minerals in the crust of the earth. By applying the necessary corrections, it is possible to eliminate solar heat component and also the heat contributions of the radioactive minerals decay. When heat is done, the residual value of the temperature distributions on the Earth's surface can be interpreted in terms of subsurface structures such as rock formations and our bodies. This is a principles and basis of geothermal method of investigations. The geothermal reservoir of the hot water that exists at varying temperatures and deep below the Earth's surface. Geothermal reservoir forms if the ascending hot water meet an impermeable rock layer. However, the water is trapped underground where it feels the force and crack of the surrounding rock. For the measurement of the temperatures on the surface of the earth, in the shallow pools or in deep or pool sensors, thermometers are used. Other instruments such as crystals, detectors, and radiation meters are used. The geothermal method find applications in deep structural studies, are deposit under groundwater studies for delineations of salt water, fresh water interface, and etc.
Good day to each and everyone. I am Ronald and I am the one who talks about electrical method. So what is electrical method? Electrical method are numerous and more versatile. They are more popular because they are successful in dealing with a variety of problems like groundwater studies, subsurface structure, and many others. Controlling properties. In electromagnetic method, electrical conductivity, magnetic, permeability, and dielectric constant of subsurface bodies are the relevant properties. Figure 1. CSEM is defined as a stationary imaging experiment that generates data sensitive to changes in sediment properties. In Figure 2, CSEM acquisition scheme and the sensitivity below the one, the PLM of the MT and the CSEM methods. Electrical method principle. Electrical methods are based on the fact that the subsurface formation, structures or deposits, and etc. possess different electrical suitably and exploited to draw the necessary conclusion. Electrical resistivity method, electromagnetic methods, self-potential method, and induced polarization methods are the very important categories of electrical methods. This is example of electrical resistivity sounding. The commonest two ways are the Werner and the Schlumberger configuration. Current is passed through the ground via the outer C. Electrodes and potential difference is measured between the inner pair P in the Werner ray and the separation between each electrode A is equal. This is the figure of electric electrical resistivity tomography imaging, short for ERI. The electrical resistivity imaging technique maps differences in the resistivity of geologic materials. These differences can result from variation in lithology, water content, poor water chemistry, or containant fumes. Electrical resistivity method. The electrical resistivity of subsurface formation vary from another if they are inhomogeneous and are studied with the help of resistivity method. In the case of resistivity subsurface, but current lines move away from it, and in case of a conductive subsurface body, the current lines move towards it. Electrical resistivity method. Profiling and sounding are two types of resistivity investigation. Profiling is done to detect lateral changes in resistivity. This throw lights on the change in the subsurface lithology or structure from place to place. Sounding. Sounding is done to determine the vertical changes in resistivity. In other words, this study reveals changes in lithology, etc. at a particular place with interesting depth. This last figure is also example of ERI or electrical resistivity imaging. That's all.
Radiometric method. The radiometric or gamma ray spectrometric method is a geophysical process used to estimate concentrations of the radio elements like potassium, uranium, and thorium in the near surface. Also, this is done by measuring the gamma rays which the radioactive isotopes. These elements emit during radioactive decay. Radioactivity is the process by which a nucleus of an unstable atom losses of energy. By emitting particles of ionizing radiations, this nucleus disintegrates in its effort to find a more stable combination. It emits a charged particle that because of its kinetic energy. Also, it is capable of penetrating solid elements. Radiometric methods. Controlling property. Natural radioactivity of rocks and ores. Principle. The normal radioactivity is different in types of rocks. In igneous rocks, it decreases with decreasing acidity if rock contains radioactivity ore bodies such as areas will exhibit very high radioactivity, giving rise to anomalies during the surveys. These studies of radioactivity, it is not only possible to distinguish different of rocks, but also to detect radioactive ore bodies. The profile drawn clearly brings out of the surface lithology, structure, and ore body. So this is the picture of radiometric methods. Instrument used in radiometric are called radiometer. These types of instrument consist of three basic components. exploration of radioactive substances such as uranium and thorium. Radiometrics methods involves in locating of some rare minerals like geological mapping, exploration of oil and gas, and groundwater studies. So this is the radiometric method instruments. As you can see, there's a picture there. And that's all and thank you.